Hello and welcome back to More Education. I'm Miss Kay and I'm going to be teaching you Group 1 Alkali Metals. Our learning objectives are to describe how the Group 1 elements' properties depend on the outer shell electrons and to explain how the properties of Group 1 elements change going down the group. The Group 1 elements are lithium, sodium, potassium, rubidium, cesium and francium. All of these elements are stored in oil. The properties of alkali metals are that they are soft, they have a low melting point, low density, and they are very reactive. Alkali metals have got one electron on their outer shell. Lithium has got 3 electrons in total. Its first shell holds 2 electrons, and then the last shell will hold the final electron. The number of shells increase as we go down the group. Because the number of shells increase, that means that there's also going to be an increase between the positive nucleus and the outer electron. Due to the weak attraction between the positively charged nucleus and the outermost electron, sodium will easily lose its electron, so therefore it's more reactive in comparison to lithium. Once it loses its electron, it will change from sodium atom and become an ion. As you go down the group, reactivity increases, atomic radius increases, melting and boiling point decreases, hardness also decreases. Now we're going to have a look at how alkali metals react with oxygen. As mentioned before, alkali metals are stored in oil. This is to prevent the metal reacting with oxygen. The shiny silvery surface reacts with oxygen in the air and quickly becomes dull. For example, lithium and oxygen will react to form lithium oxide. Sodium and oxygen will react to form sodium oxide. And below each word equation are the balance symbol equations. Whenever an alkali metal reacts with oxygen, a metal oxide is formed. Now, reaction with chlorine. Alkali metals react vigorously with chlorine gas to produce metal chlorides. Reactivity increases as you go down group 1. The electron on the outer shell becomes easily lost to form 1+ ions. For your exam, you'll have to know examples of word and symbol equations for this reaction. When alkali metals react with chlorine, they form metal chlorides, and we'll have a look at 2 examples. So here is lithium and here is sodium, and their balance symbol equations as well. Now we're going to go through key points of what you will need to know for your exam about how alkali metals react with water. They react vigorously, they move or float on the surface of the water. Fizzing or effervescence, there's a release of a gas, and that gas is hydrogen. Reactivity increases as you go down, as mentioned before. And you need to know that potassium produces a lilac flame. In school, your teacher will demonstrate lithium, sodium and potassium. The reason why the rest of the elements are not demonstrated in school is because the reactions are too vigorous and it is not safe to do it in school. Now for the word and symbol equations. Lithium plus water gives lithium hydroxide plus hydrogen. And sodium plus water will give sodium hydroxide plus hydrogen. So the general equation would be a metal plus water will give a metal hydroxide plus hydrogen. Now for the progress check. Pause the video, answer the question, and when you're ready, press play. Okay, question 1 asked, why are alkali metals stored in oil? The answer is that they are very reactive in the presence of air, water and chlorine. Question 2. Explain why the reaction of potassium with water is more vigorous than the reaction of sodium with water. Group 1 atoms lose outer shell electron during reactions. As you go down the group, the distance between the outer electron and the nucleus becomes greater. Therefore, the electrostatic force between the positive nucleus and the negative electron gets weaker, making it easier to lose an electron. That's all for now. Thank you for watching this video and I hope you have gained some more knowledge on alkali metals.